now we're going to look at factoring three-term polynomials where a is not 1 using the AC, or some books will call the grouping method. They mean the same thing. Either one is the same method. So why it's called the AC method. The deal is, if you're given a polynomial like this, it's a trinomial, a is not 1. In this method, what you have to do is identify what a, b, and c are, and you look at what a times c is, and then you look at the factors of those, and you say what factors of those add up to be b, which is 19. Just like the quick way thing that we were doing, except for the thing is, you're not dealing with a as 1, so you can't just look at the factors of c that add up to be this. You're looking at a as being a number other than 1, so you have to consider that into it and multiply it to the c. So this is a method that most full-time faculty I know here on this campus, or I mean at this college actually, kind of steer students away from. They usually will pick like a trial and error method or some form of a crisscross. I personally really try and steer you towards the crisscross. I really like it. I've been doing it for like 3 years now, the crisscross, and I've seen much better results in student testing. But I really like the trial and error myself. A lot of people really struggle with it. And then also a lot of people are really good at systematic things, and if you're somebody that, when you read directions, you gotta, you get I guess the analogy I like to use is, if I get a present for Christmas or something, it requires putting something together. I'm somebody that's just going to put it together and not really follow every single direction, and an extra parts and look back later. If I have extra parts, I'll just leave them off to the side and it's good to go, but I like to get to the answer. So some people are the type of person that would like to follow every single step, detail by detail, until it's done, and it may take a lot longer, but it's done, it's done right, it's done, the crisscross and the other methods are going to be done right, but the thing is with this method, it's really nice and systematic like that. But there's some major disadvantages to it. Main disadvantage, I think, is time. Another major disadvantage is when you have big numbers here, these aren't too bad, but when you start getting anywhere in the 20s, bigger numbers, it's a lot of times really hard to find the factors that add up to be b, and it can take you a crazy amount of time and is not needed when you can just do a really quick crisscross method, so or trial and error. So anyways, that's my plug for the crisscross. I still think crisscross is probably the method I would choose if I'm first learning this, but I want to show you this. It's still a good method. They're all good methods. So I'm factoring this thing. I recognize it's 3 terms. A is not 1. That means it's going to take some more work than a normal problem. And so I identify A, B, and C if I'm using this method. And then I look at what are the factors of A times C, which when we multiply 6 times 15, I should get 90. So it's a pretty big number. But luckily it's going to work out pretty nice. I'm recognizing in this one that sum to equal b, and b is a positive 19. So you can actually start listing all the factors of 90, starting with 1 all the way down, but all you have to do is find the 2 factors that multiply to be 90, add it to be 19, and those kind of jump out at us, I think, because it's 9 times 10, right? So if I looked at this and I went 9 times 10, I get 90, and 9 plus 10, I get 19. So that's the factors that I'm going to use. And so our goal is, why they call it the grouping method in a lot of books, is because what we're going to do is break this up into a 4-term problem and factor by grouping, just like we did with the 4-term problems. So we use these as coefficients to split up the middle term. And so that's all I'm going to do. I'm going to take this, and I'm going to rewrite this as 6x squared plus 9x plus 10x plus 15. All I did was rewrote this problem using this as coefficients in the middle term to break it up into 2 terms. And instead of writing 19x, I wrote 9x plus 10x. Now I have a 4-term polynomial. Cool. Sitting good. I could actually put the 9 in the back if I wanted to, and the 10. It doesn't matter which direction you do it, but I'm going to group them how we learned the 4-term ones. And so I see that the common GCF of the front 2 is a 3x. What's left will be 2x plus 3. In the back, I see I have a common 5 that I can take out, and I'm left with a 2x plus 3. And then you'll notice, cool, I have a common binomial factor that I can take out, and it's 2x plus 3 times what's left, which is 3x plus 5. And you're done, you just factored it. So that problem, it worked out pretty nice because the factor, even though 90 is a pretty big number, b was 19, and it was kind of, visually you could see that. But it can get really tricky if they're big numbers. And I think you could still factor it faster with the crisscross, and it'll also help pick the signs for you. So anyways, that's factoring using the AC or grouping method.